Welcome to the Beyond Tech podcast, a podcast designed for engineers. We aim to demystify technologies around safety and give you all the information that you need in order to make an informed decision when designing a safety system.
We cut through the fluff and we try and avoid those generic statements like robust and reliable. And we take a look at the technologies in the challenges of the real world rather than just looking at the data sheets that only references best case scenarios.
Each episode will take on one gas or flame detection technology and break it down, how it works, when and where to use it, potential drawbacks, and any maintenance requirements.
And in this episode, we're going to take a look at flame detection, and there is no better guest to invite on the podcast than Lars Wulf, our PM for flame detection. Welcome, Lars.
Welcome.
Good morning. Many thanks.
So Lars, you started with Dräger in 2000 as a student in the R&D department, but more recently you're the product manager for the flame detectors. So welcome, and as is custom with all of our guests, we're going to subject you to a little icebreaker. Is that okay?
That is okay, that's fine.
So a few questions are this or that option, and we take your best and first answer. So early bird or night owl?
Early bird.
Coffee or tea?
Coffee.
Cats or dogs?
Dogs.
Pizza or burger?
Oh, that's difficult. Burger.
And a holiday, is it city break or country escape?
Country escape.
Lovely.
Very
I've
good.
noticed everyone so far has said coffee. Is it black coffee by any chance?
No, it should be a bit of milk.
A little bit of milk.
Yeah,
Nice.
yeah.
I agree. So let's start with the basics. What is a flame?
Yeah, how I explain that best. It's a visual reaction. It depends on fuel and of course of oxygen. So it's called this process called combustion. Mm-hmm. And during the combustion we'll get a lot of energy from heat, light, and reaction products like CO2.
Okay.
Mm-hmm.
So like going back to the school
I was just about to say
scenario,
the fire triangle.
yeah.
Yes.
So it's fuel,
Yes.
oxygen,
Correct.
and heat, and then of course there's the expelled gases like CO2. Is there anything other than CO2?
It could be also hydrogen, if we are detect hydrogen, but normally if we are looking on hydrocarbons, where we're looking for the typical IR detectors or UVIR detectors, it would be CO2.
Yeah. Any water vapor coming off flames?
Yes, of course. It will also some water vapor that coming from flames.
So under the umbrella of flame detection, we have three different technologies we're going to take a look at. We have the infrared, triple IR, the UVIR, and the visual flame version. So we're going to take these three as separate podcasts and go through each technology one by one.
Make sure that you head to the podcast episode that you're interested in and that you can see the flame detection technology that you need. So we'll get started with triple IR. How does it work?
A triple IR detector, it's so typically, as it is called in the name, it's a triple. So we have three different IR sensor elements in the detector. One is dedicated as a measurement signal, so looking at the CO2 bench, and the other one will be close to that, but outside the CO2 bench to compensate effects like temperature, humidity, or other things. So due to this, it's really robust to false alarms. Because if you only have a single, then you're looking on each and every hot exhaust or other things that could emit hot CO2. And due to this, you always get false alarms or a lot of information. So, and due to this, it's easier to see.
And by all, we are talking about infrared, correct? That's
Yes.
what it stands for.
Yes,
Yes, just to clarify.
it's infrared, of course, and due to this, the detector also looking to the spectrum, the typical spectrum of CO2, and also looking to the flicker, the result of a flame. So if you have hot radiation from a hot surface, that's a steady emission and nothing that will really flickers. So the combination would be interesting for an IR detector.
Yeah. And this is not the spectrum that like the human eye can see.
No,
correct.
It's an infrared spectrum outside the human eye.
So so just to get that straight, so you have one measurement infrared band,
Correct.
and you're referencing the other two to sort of create that fingerprint or
Yes.
a typical pattern of a
Yes.
flame. Okay.
So
it's a moving target typically. So when would we use triple IR? When's it? We've got three technologies to look at, when would you select the triple IR?
Normally, if you need a reliable detection, and of course don't get rid of false alarm sources, because due to the 3 different IR sensor batches, you have the best result. So otherwise, if you combine that in different areas, you maybe get in trouble with the environmental situation. So with sunlight, with vibrations, with other things, and with the IR, you have a strong behavior.
Okay. So what would be the main source of a false alarm if you didn't use IR?
Hot CO2 emission,
CO2. Okay.
maybe from an exhaust or from a flare. That's the main problem. If you're looking maybe on an application where you have a flare burning, and you look with the IR detector to the flare, then of course you get in trouble, because you always get an alarm on the detector.
And with the response time of triple IR, is this a detector that has a quick response time?
It has a quick response time, to be fair, but it depends on the size of the fire, to be fair, and the distance to the fire. So if we are closer to the fire and have a big fire, then of course the result is much better, because you get a higher signal to the detector. If it is far away, then of course it could get some trouble. So, and also if you have some problems with the lens, so the lens should also be clean of a detector. If something is on the lens, like oil or water or something, the emission will go down, and due to this also the response time will go down.
Are flame detectors also for 20 milliamp devices as well?
Yes.
Is that what they output?
The output is typically 4 milliamp for a healthy situation, so no fire, and 80 milliamp for fire detection.
80.
18.
Oh, 18.
18, sorry. No, 18 for fire.
Okay.
We looked a little bit, well, you mentioned response time there. So what would you typically expect a response time for a triple
below 5 seconds? It's typically. There's also some solutions that you have a fast response time for detectors, but to be fair, if you configure a detector on the fast response mode, you will see also some other things in the application. So if there is high emission of CO2, you nearly close to false alarm sources, and you have to be careful with this. But typically, if we are working in a standard mode, it will be around about 5 seconds, depends on how big the fire is and how far the distance of the fire is, but that's the typical.
So that's interesting. When you look at these data sheets, they probably only reference the quick speed setting. So is that typically, in a real world scenario, would you not advise to go for the quicker speed, or would it just need to be aware of what's surrounding that environment?
If you would like to have a reliable detector, it's not recommended to go to the quickest speed. If we are indoor, if we have safe environment, if you are close to the fire, then of course fast response, it's easy to use. But if you're outdoor and have a lot of environmental effects, it makes no sense, because you always get in trouble with false alarms there.
So I suppose if your coverage is good enough and you have enough coverage on that location, then maybe the speed of response between 5 and 2 seconds.
Yes.
It may not be worth it, right? Because just to reduce false alarms potentially.
Yes, correct.
Okay.
So we spoke a little bit about distance and coverage there. Do these detectors have a sort of field of view, like a standard field of view, and a range as well? Like, how far can they detect?
As I explained it before, if we are talking about the detection range, typically for the typical substances, we have a detection range of round about, maybe call it 50 meters. So as a typical detection rate, it could be higher, it could be also less. It depends on the substance. It depends on how big the fire is, and if there is a clear field of view for the detector. Because if there is something in the field of view of the detector, then of course it will be blocked, the emission.
Is that field of view like a cone?
Yeah, it is like a cone, and that's also be a problem. The performance will be gone with a cone. So inside the cone, the performance would be good, of course. If you come to the edge, then of course it causes some problem. It would be weaker. And also, if you have a small fire to the end of the detection range, it could not see as best as you have a bigger fire to a close detection.
Okay.
Okay, so the distance quoted
Yes.
is typically not the full distance as you get wider on that
Correct.
field of view. Okay.
Correct.
That's important when you're looking at location. Yeah.
So how would someone know where to place these devices? Because you wouldn't always necessarily understand where there may be a fire, I guess, on site. Or would you know?
No, normally you have to do something like risk analysis to see where could be a typical fire, maybe from a valve or something like this, where you get an exhaust of something that could be burned. So, and of course, to have the right coverage, you look what the detector could see. So you look into the field of view of the detector, and if it's a clear line of sight, you could detect everything that is there. You could not see something that is on right or left of the detector.
Yeah.
There's no chance because you don't look in the
You
direction.
need another one.
Yes, you need another one for this.
Yeah.
So it's not possible with the same detector.
Okay.
So with triple I has been used for a number of years, right? So, but with the energy transition, so looking at new flame fuels, for example, hydrogen, ammonia, would you use triple IR? Because we discussed in another podcast that you can't detect hydrogen with infrared. Is that true with flame?
For flame, it's not true. For flame, we have a dedicated measurement element in our triple IR detector. It's a special detector. It's different to the hydrocarbon version. We could not use the hydrocarbon one because we are looking of the spectrum of CO2. So it's not the same like for hydrogen. And due to this, we need different wavelengths for the different sensor elements. But the rest of the detector is completely the same.
Okay.
With the same advantages like we explain now for triple IR technology, you could also use for hydrogen.
Yeah. Okay.
The detection range is a bit lower, to be fair. It's around about 30 meters, so typically. But for the rest, we have the same advantage like we have for the typical IR
So you're
technology.
looking for the water vapor off a hydrogen flame, for example.
Correct.
So if you were to select that, because I guess not all flame sources or flame fuels are pure, right? So a hydrogen fire would then set fire to something else, right? So if you had a flame in that scenario, would the hydrogen infrared be able to then pick up the flame with different fuels?
Yes. It could also detect some hydrocarbons, but not as good as the typical hydrocarbon version, to be fair.
Okay.
So if you would like to cover both in one application, it could be possible that you could use that. Normally, we have to check what substances are the critical ones in the application, and then choosing the right detector. Or it could be, at the end, also two different detectors in the application, one for hydrogen and one for hydrocarbon.
Okay.
You mentioned a little bit about like grease and oil on the lens. Is there any other environmental factors that can act as a drawback on the detection?
Yes, if we have a lot of fog, rain, smoke, something like this, that could be block the CO2 emission that goes to the detector. And due to this, the signal could be much weaker than if there's no fog or there's no rain.
Yeah.
So I guess that's taken into account when you're doing maybe a mapping study. So if you're installing by the coast and there's regular fog, I guess you then shorten that distance. Is that?
Yeah, maybe shorten the distance and also maybe protect the detector itself. If we know that there could be a lot of rain in this area, it would be better to use a weather shield on the detector to be on the safe side, because then you have a better coverage of the lens. It's not the best coverage in the end. If you really have storm and fog in the front of the lens, then it's difficult.
Sure.
But for the rest, you could cover the unit itself or the detector itself, and that could be done by the weather shield. And of course, the detection range could also be an option if we are in critical environments. Maybe closer is much better than a higher detection range.
Okay, is the lens heated in any way to get rid of humidity? Okay.
Yes, it's heated inside, but it's clear if you have a lot of rain or water on the front,
it's only so much it can.
Then it took some time to get the water away.
Okay, and then in terms of the installation and how you install it, what do we need to look at? Is there any special?
Yeah, typically, of course, the first step is you have a clear line of sight. So you could see the whole area that you would like to detect or to cover. It should be without any vibrations.
Okay.
So And of course, if you need some protection for the detector, a weather shield or something could be good to use.
Yeah.
And normally we are installing the detector a bit higher and looking downwards with an angle around about 45 degrees.
You mentioned vibration. Why is that important to try and avoid?
Because due to the signal stability of the detector, so if you have a high vibration, you don't get a good signal in the unit itself.
Okay. And when you're mounting and installing these detectors, is there a way for the person that's setting it up to actually see the line of sight, see what the detector sees?
The best way is at the end to use a flame simulator.
Okay.
And go close to the part where the fire could be burned, and then activate the detector via flame simulator.
Ah, so you are the flame.
And you are the flame. And then, of course, you could see, okay, everything is fine. The detector could see the fire and will react on the fire. And you also get the feedback to the gas or fire detection system.
Okay.
How does that flame simulator work?
It's just emitting hot CO2, so spectral. You have the spectrum of an hot CO2, and of course you have the flickering.
Okay.
Because it's flashing. So, and due to this, it looks like a fire for the detector because he's looking on both.
Yeah.
He's looking on hot CO2 emission, and he's looking on the flickering of the flame, and he gets both from the simulator.
Okay, so you don't need access to the sensor. So when you say you install it at a height and looking down, you don't need to have regular access to that.
No, of course.
Device.
If we are talking about maintenance, then of course it makes sense just to step to the detector to maybe clean the lens, checking the detector if something is wrong from the wiring or whatever. That has to be done once a year, but there is no need to have a calibration on the detector itself.
Okay. Yeah. Okay.
If you do an update or you change something in the configuration of the detector, then of course it makes sense just to do a calibration to test the device, but normally it works the whole year without any maintenance needed.
So on to calibration and maintenance procedure and process. How often do you have to take a look at that?
It depends on the application.
Okay.
If it's a clean application, I think it's clear that there is no problem that something coming on the lens or block the lens. But if you have maybe a dirt application and you have strong weather in the application, then it makes sense to step once or twice a year to the detector, cleaning the lens, checking the device if everything is correct.
So it's site specific.
Yes, site specific, it's clear. And of course, it's always good to do a bump test with the flame simulator to check if everything is okay, if everything is fine.
Yeah.
Maybe it could be that there's a requirement from the customer to change the detection range of the detector because the area is maybe closer where the fire could be activated, and due to this, it's also be good to check the unit again.
Yeah, I guess a site never stays the same, right?
Yes.
Installs. And stripping out. Okay, so for me, that's a comprehensive view on triple IR, but what we'd like to do is have 3 questions just as a takeaway for the customer, so the 3 most important pieces of information. So the first question is when we would use triple IR, when is it the correct choice?
It will be the best choice if you would like to have a reliable hydrocarbon or hydrogen detection for a flame.
Okay.
And then the second question is the biggest limitation or misconception that people have?
The biggest limitation could be if you have harsh environment, so you get problems with fog, rain, smoke, or other things that could be blocked the signal transmission from the fire to the detector.
Yeah.
And the most important thing to think about when looking at maintenance?
Cleaning the lens and maybe testing the device with the simulator to be on the safe side, like that is working fine.
Perfect.
Very good. Thank you, Lars.
Thank you.
Well, that's a wrap for this episode. If you need any further information on the technologies to help design your projects, then you can go to our website, Dräger.com/EPC, where there's a whole library of information that you can use for your next project.
We hope you found this podcast useful or beneficial, and don't forget there's 2 further flame episodes coming up, so be sure to check them out as well.
In the next episode, as Megan said, another technology, but the rules are the same. No talk of product, no fluff, and looking at what survives real projects.
Yeah, thank you.
Thank you.
Yeah, many thanks.